right, guys, so I just want to quickly go over the final. I'm going to be releasing the scores, so I wanted you to be able to look at this video and realize maybe what you did right, what you did wrong, so you could better understand your scores. So the first question is, Miss Sandy solved the quadratic equation below by factoring. Each line shows her work step by step. She got -6 and -1 as her solutions explain what she did wrong. So hopefully you guys remember that in order to factor, the equation does have to be equal to 0. So if you notice from the first line to the second line, I'm just starting to move stuff all over to one side. So I'm moving -x squared over to the other side by adding it. So that's how it becomes the positive here. And then the next step would have been to take that 3x and move it to the other side. And that's where the mistake is. So it should have been -3x, and instead I added it and got 7x. So for the first question, all you were supposed to do was talk about how technically I didn't combine my like terms correctly. And I got 7x instead of 1x. It should have been a 1x. 1b says, how do you know for certain -6 is not a correct answer for x? So if you guys ever want to know if your solutions for x are correct or not, you're just plugging them back into the equation. So if I were to plug in -6 back in for x here, here, and here, if the equation was equal, so if whatever I got on the left side is equal to what I got on the right side, then the solution is good. But if it's not the same thing, then it's no good. So that was how you know for certain -6 isn't the right answer. When you plug it in here, I believe on this side you get like negative, well, let's just do it really quick. So 4 times -6, that's -24. And then -6, so that's -30. And then on the other side, you would get -6 squared, which is just 36, 6, 12, 18, the -18 minus 36, whatever that is. Obviously, the left side isn't equal to the right side, so. But hopefully you guys knew that the right answer that I was looking for there was that anytime you ever get an answer for a variable, you should always be able to plug that back into the original equation. And if it's true, then it's a solution. And if it's not true, then it's not a solution. Part C says to provide the correct solution for the problem. So moving the terms over, I'm just going to kind of say this verbally, but you should have gotten x squared plus 1x minus 6 equals 0. So this 7 should be a 1. What you're looking for is two numbers that multiply to -6 but add to 1. And that should be -2 and +3. So right here you could put a -2 and then a +3. And then when you solve them, you'll get 2 and -3. So those were the answers, 2 and -3. And that's the first question or section of the final. The next one was all about the y-intercept. So I want to know if whatever image or information you're given, does it have a y-intercept equal to 5? And you needed to support your answer with y. So each one was worth 10 points. So I gave you guys 5 points if you answered correctly, yes or no. And then the other 5 points came from your reasoning. So for the first one, this was the first one. So the answer is no. The y-intercept at 5 would be right here. So that means that the graph would have touched the y-axis at 5. So no, it doesn't have a y-intercept at 5 because the parabola is not touching at the point 0.5. Here's the second one. So this one is yes. So here's the y-intercept at 5 and the parabola is touching there. So you can clearly see that. You could just explain the parabola is touching the y-intercept at 5, or the parabola is touching at the point 0.5, which is the y-intercept. The third one you're given a table. So for this one, some of you had just stated Yes, because y is 5. But you have to be a little bit more specific to that, because what if there was a 5 here? You have to mention the x also. It's not just about what's in the y column or row, it's also about the x. So this one is yes, because when x is 0, y is 5. So that's a point right there, 0, 5. So you can't just mention the 5, you needed to mention the 0 too, because that's important. A y-intercept will always have 0 as x. So that was really, really important. So the answer is yes. And then don't forget that you needed to mention 0 for x, and then the 5 is y. For the next one, it talks about a golf ball is hit off the ground and is in the air for 5 seconds. Okay, so this one, the answer is no. There's a few ways to say this, but if a golf ball is getting hit off the ground, that means the height is at 0 seconds. So that means that the starting point is at the origin, which means 0, 0. If you're starting something at 0, 0, there's no way it can have a y-intercept at 0, 5. If you have a y-intercept at 0, 5, that means that the ball wouldn't be on the ground. It's in the air. It's starting in the air. So maybe it's like in our hand. But this one says the ball's on the ground. So that means it's at 0, 0. A lot of you guys mentioned that it talks about 5 seconds, which 5 relates to time. And that is true. But you needed to also mention height. So if the ball is on the ground, height is 0, 5 seconds. I just needed you guys to be either mention both if you talked about 5 seconds referring to the x-axis, or just tell me that if we're starting on the ground, then that's at the origin 0, 0. So something along those lines. For this one, so this time you're given an equation. So if you want to know if it has a y-intercept equal to 5, remember, if y-intercept is equal to 5, then the x value has to be a 0. So you should have just plugged in 0 here, 0 here. And if it came out to 5, then that's where the y-intercept is at, and that's exactly what it was. Some of you guys went and graphed this, which would have took way more work, and that's not what I wanted you to do. I wanted you to work with what I was giving you. But I didn't take points away if you told me you graphed it, because you still got it right, but that would have been the quickest way. If there is a y-intercept at 5, that means 0 is x, and you would have just plugged that in, and that would have been a really simple equation to simplify or solve. So that was the second one. The third one is this one right here. So it was kind of you guys interpreting a parabola and also a quadratic equation in standard form. So a quadratic function and a quadratic equation. It's talking about the soccer ball. So they represent kicks of a soccer ball. So the directions say to choose any of the following 2. So I listed out 3 different questions, A, B, and C. And you guys were to choose 2 of them. Each one is worth 25 points. But I am looking for a pretty good explanation for each one. So for A, it says, which function represents a higher maximum height of the soccer ball? So like right away, your clue word there is maximum. If we're talking about maximum, we're talking about the vertex. So height refers to, if you look at even a graph, like remember that time represents x and then height represents the y. So you're looking at, if you had a vertex, which y value is higher. So this one, you could just look right at it. So I see the vertex is at 216. So that means that the ball goes 16 feet high. Now for the equation, you needed to find the vertex. So that's when you would have used opposite b over 2a. So the opposite of b would have been -4 divided by 2 times -2, which was -4. So it would have been 1. So then you would have plugged 1 in for x. If you plug 1 in for x, you would have got -2 plus 4, which is 2, plus 6, which is 8. So this one had a height of 8, and this one had a height of 16. So which one has a higher, which one is the soccer ball going higher? It would have been the g of x, the graph. The second question says, which is greater, f of 1 or g of 1? That just means if you plugged in 1 for x on both, which one's greater? So the graph is easy. If you plug in 1 for x, we're at 12. So I know the answer for this one's 12. If I plug in 1 for x on this one, that's 8. We just actually did that. So which one's greater? G of x. When I plug in 1, I got 12. And the last one, it says one function represents the ball being kicked from the ground. The other function represents the ball being kicked in the air. Explain how you tell which function represents either situation. So for the graph, it's really easy to tell. For this one, I know it's getting kicked from the ground because look at where it's starting at 0, 0, the origin. So whenever it starts at the origin, that's how you know your ball's on the ground, it's being kicked from the ground. For this one, remember that when you have a graph, right? When time is at 0, that's how you know where your starting height is. So when time is at 0, height was at 0. So the same thing goes for the equation. If time is at 0, remember x is time. You would have plugged in a 0 here, a 0 here, and when you solved it, you would have got 6. So that means 0, 6 would have been there. So that parabola would have started right there. Now that's not on the ground. So that's kind of how you know the difference. So on a graph, origin at 0, 0 from the ground. For this one, the C term actually always tells you what your initial height is. And if the C term is a 6, then that's the height you're starting at is 6. So something along those lines would have been an answer I was looking for there. And then the last one, which was my favorite one. So this last one was talking about Captain Hook looking for his treasure. So there was a diagram given that kind of showed how to get to his treasure from his ship. And it talked about how Peter Pan used trig functions to figure out how deep the treasure was. But then Wendy used Pythagorean theorem. And so I just wanted you guys to explain why they both were correct. So explain how Peter Pan would use trig functions. I got a lot of different answers for this, but a lot of them came out to the same answer. So there's many ways to do it with the trig functions. I would have started with, so the angle 22.6, you did not need to find this angle. It wasn't necessary. Some of you did find it, but you didn't need to find it. So if I were going from this angle and I want to find this length, I'm going to choose a trig function that involves this side. This is the opposite side. And then I'm going to pick another side. So opposite, you could have either chosen opposite and hypotenuse, which would have been sine, or you could have chose opposite and adjacent, which would have been tangent. So it depends. So let's say you did sine. So your equation should have said sine 22.6 equals x divided by 78. And then you would have explained to me how to solve that. So some of you just set the equation up and that was it. But you needed to explain to me how you solve. So multiply both sides by 78. Find out what sine 22.6 is and multiply it by the 78. And then whatever the answer was, it was rounded a little bit. And that's how they got 30. If you use tangent, it would have been tangent 22.6 equals x over 72. And then you would have explained to me how to solve for the tangent, or solve for x there using tangent. So that was that one. I even had some people figure out this third angle, and then they figured out a cosine one. And I did read them all, so if you did that, I still gave you full credit too. But that probably wouldn't have been the initial way I would have went. But it does work. And then Pythagorean's theorem. So for that one, you would have said it's a right triangle. So as long as you said it, as long as you substituted it into Pythagorean's theorem correctly, it should have came out okay. So it probably would have looked something like x squared plus 72 squared equals 78 squared. Once you square them, you would get x by itself, and I think it's like x squared equals 900. And then to get rid of squared, you would have taken the square root. So the square root of 900 was 30. So it should have looked something like that. But that is it. So hopefully you guys have a better idea of how your final was graded. And if you have any questions regarding your score, just let me know.